Hey everyone, welcome back for another deep dive. Today we're looking into something that's kind of a study of studies.
Ooh, meta.
Yeah, exactly. It's called meta-analysis.
Right?
And meta-analysis basically takes a whole bunch of different studies that have looked at maybe the same question or similar questions and tries to kind of come up with an overall conclusion.
Yeah, combine those findings.
Exactly. And so what's really interesting about the deep dive today is we're actually looking at research that compares different ways to do meta-analysis.
Oh, so meta on meta.
Yeah, meta on meta.
Yeah.
So hopefully by the end of this, you'll be a super savvy consumer of research.
That sounds great.
All right, so let's just imagine that we're looking at a bunch of studies that have looked at the relationship between how satisfied somebody is at work and how well they perform.
Okay.
Do you think that there might be other factors like, I don't know, say gender or the size of the company that a person works at that could influence that connection?
Absolutely. And you're talking about moderating effects.
Yeah.
Which is basically just, another factor that changes the relationship between two things.
Oh, right.
And, oftentimes we think about relationships as very simple, like A plus B equals C.
Yeah.
But it's rarely that simple.
Yeah. And that is exactly what Aguinis, Sturman, and Pierce,
Guinness like the beer.
yes, exactly,
Okay.
explored in their research. So what they were looking at is how well three different methods of meta-analysis handle these moderating variables, but specifically categorical moderator variables. So things that are either one thing or another.
Okay, got it.
So think of like gender, male, female.
Okay, makes sense.
And so they really wanted to see, okay, if we've got these different methods of meta-analysis, how well do they actually find those moderating effects when they're there?
Interesting.
Yeah, so to do this, they actually simulated a massive number of meta-analyses.
Oh, wow. How many are we talking?
We are talking over 656,100.
Whoa, that's a lot of data.
Yeah, so they had their work cut out for them. And so they manipulated different things. They looked at, how many studies were included in each meta-analysis. So some had 10, some had 50, some had 100.
Oh, wow.
They looked at different sample sizes in the original studies. So,
Yeah.
some were small groups of like 20 people. Some were, bigger, like 250 people. They looked at the strength of the relationship. So, is it a weak correlation, medium, strong?
Gotcha.
They even looked at how much measurement error and range restriction there was in the data.
Uh-huh.
So they were really trying to kind of cover all their bases.
Wow. Very thorough.
They were. So with all of that being said, I'm really curious to know what they found. What was the big takeaway?
Well, I guess the first thing to note is that when it came to just estimating the overall relationship between whatever two things they were studying, right?
Mm-hmm.
The Hunter and Schmidt method was the most accurate.
So they were really good at cutting through all that noise.
Exactly. Cutting through the statistical noise and, getting to the heart of what is the actual relationship here. However, there was a bit of a weakness, and this actually applied to all three methods.
Oh.
They all struggled with what we call type 2 errors, which is basically when there is a moderating effect, but the meta-analysis misses it.
Oh, so it says, nope, there's nothing going on there, but actually there is something going on there.
Yeah, it's like saying, gender doesn't have an impact on the relationship, when really it does.
Right, yeah, and that could lead researchers to draw some like incomplete or inaccurate conclusions.
Exactly. You don't want to miss those important nuances.
Right.
That's really the danger of type 2 errors.
Interesting.
So that was a consistent finding across all three methods. But interestingly, the Aguinis and Pierce method did have a slightly better chance of catching those moderating effects, especially when there was a lot of what we call range restriction in the data.
So range restriction, kind of break that down for me. What does that mean?
So range restriction basically means that the data you're looking at is limited in some way. Like imagine if a study only looked at CEOs. Right.
A very specific group of folks.
Exactly. It doesn't represent the full range of employees that you might find in a company.
Right.
And so when you have that kind of limited data, it can be harder to detect real moderating effects.
Gotcha.
So the Aguinis and Pierce method seemed to do a little bit better in those situations.
Interesting.
At kind of accounting for that and still being able to find those moderating effects.
Wow, that's fascinating. Okay.
Yeah, so there's definitely some trade-offs to consider when choosing a method for meta-analysis.
And this is so interesting because I think a lot of times people think about research findings as very cut and dry, like this is what the research says.
Right.
But this really highlights that like even how we analyze the research can influence the conclusions we draw.
Absolutely. It's not just about the data itself, but also the methods we use to make sense of it. And that's why it's so important to understand these different approaches and their potential strengths and weaknesses.
Yeah, and I think it also just emphasizes the importance of critical thinking when it comes to research.
Mm,
It's not just about blindly accepting the findings, but really digging a little deeper.
exactly. Asking questions and considering alternative perspectives.
Right.
That's how we get to the real truth.
Awesome. Well, this has been super insightful.
Yeah, this is really interesting stuff.
So I'm curious to hear more about how these different meta-analysis methods actually work. Like, what are they doing with the data?
Yeah, let's dig into that a little bit more.
All right, let's do it.
So to really understand how these different methods work, we kind of have to understand this concept of homogeneity.
Okay, so break that down for me. What is homogeneity when we're talking about meta-analysis?
So, think about like baking a cake.
Okay.
You want all of your ingredients to kind of blend together smoothly.
Yeah.
And so in meta-analysis, homogeneity is this idea that all of the studies you're combining are similar enough to be analyzed together.
Okay.
If they're too different, then the results can be kind of misleading. It's like mixing, cake batter with cookie dough.
Yeah, you're going to get a weird result.
Yeah, you're going to get something strange and probably not very tasty.
Right.
So these different methods have different ways of kind of assessing this homogeneity.
Okay, so how do they do it? How do they test it?
So, for example, Hunter and Schmidt use what's called the 75% rule.
Okay.
And so they're trying to figure out how much of the variation between studies is due to just random stuff like random errors in measurement or quirks of sampling.
Yeah.
And if more than 75% of that variation can be explained by these random factors, then they're like, okay, there's probably not a real moderating effect happening here.
So they're saying it's mostly due to chance, so let's not get too excited.
Exactly. Yeah, we're just seeing noise.
Okay.
Now, Hedges and Olkin use a statistical test called the Q statistic.
Okay.
And this basically looks at the effect sizes.
Now, hold on. What is effect size for people who don't know?
Yeah, so effect size is basically a way of measuring how strong the relationship is between the two things you're studying. So like a large effect size for exercise and weight loss would mean that there's a very strong link between the two. Like more exercise leads to a lot more weight loss.
Gotcha.
A small effect size would mean a weaker connection.
Okay, got it. So back to this Q statistic.
Right. So the Q statistic looks at the effect sizes from all the different studies in the meta-analysis and sees if they're more spread out than you would expect just by chance.
So if they're kind of all over the place, that's a sign that there might be something else going on.
Right, exactly. It suggests that there might be a moderating effect happening.
So it's like if you were looking at like a map of earthquake activity
Okay, yeah,
and you see a few tremors scattered around randomly, that might not mean much.
right.
But if they're all concentrated in like one particular zone,
Yeah,
then you might suspect there's like a fault line or something causing that.
exactly. That's a great way to visualize it.
Okay, so Hunter and Schmidt, 75% rule hedges, and Olkin Q statistic. What about Aguinis and Pierce?
So Aguinis and Pierce is kind of a hybrid approach. They actually try to do both.
Oh, wow.
So they first try to correct each study's effect size for those artifacts like measurement errors that Hunter and Schmidt are focused on.
Oh, yeah.
But then they use a modified Q statistic to see if there's still significant variation between those adjusted effect sizes.
So they're kind of cleaning things up a little bit first and then seeing if there's still something interesting going on.
Exactly.
Oh.
And remember we talked about how all three methods struggled with those type 2 errors, like missing real moderating effects.
Right. Yeah.
Aguinis and Pierce actually did a bit better, especially when the data had a lot of range restriction.
Okay, so range restriction, what is that?
Yeah, so range restriction basically means that the data is limited in some way. So like I said before, if a study only looked at CEOs,
Right.
that's a pretty restricted sample. It doesn't represent the full range of employees within a company.
Gotcha.
And when you have that kind of limited data, it can be harder to spot true moderating effects.
So in our example of job satisfaction and job performance, if the researchers only studied employees in, say, the marketing department, then the Aguinis and Pierce method might be more likely to find an actual gender difference in how job satisfaction relates to performance.
Exactly, because they're acknowledging those limitations of the data set
Okay.
and trying to adjust for that.
This is fascinating and also a little overwhelming because I'm thinking if all of these different methods have all these different nuances, how can we, as just regular people reading research studies, how can we ever know like what to trust?
Yeah, you've hit on a really important point. It's not about blindly accepting research findings. We have to be savvy consumers of information.
Yeah, so how do we do that? What are some things that we should look for when we're reading a research study or, I guess, a meta-analysis in this case?
Yeah, that's a great question.
Yeah.
I mean, I think first and foremost, look for a clear description of the method that they used.
Okay.
Did they just lump all the studies together, or did they actually test for homogeneity
Right.
to make sure that the studies are similar enough to be combined?
Okay.
Did they account for things like measurement error and range restriction?
Yeah.
If not, then, the results might be a little bit misleading.
So we really do need to be like critical readers and look beyond just kind of the headlines.
Absolutely. And, don't be afraid to dig into the details.
Yeah.
Like, look at the sample sizes, look for potential biases.
Okay.
And, see if the authors acknowledge any limitations in their study.
Yeah.
Because research is a process of continuous discovery.
Right.
What we consider true today might be refined or even overturned by new evidence tomorrow.
Right. Right. This has been such an insightful deep dive. I feel like we've learned a lot about meta-analysis and these moderating effects.
For sure.
But I think even more importantly, just kind of that idea that how we analyze research can really have a big impact on the conclusions.
Absolutely. It's not just about the data itself, but also the methods that we use to make sense of that data.
Right.
And I think it just underscores the importance of critical thinking when it comes to any kind of information that we're consuming.
For sure.
Yeah.
For sure. So don't just take things at face value. Ask questions.
Yeah, look for evidence.
Be open to different perspectives.
Exactly.
All right. Well, this has been fantastic. Thank you so much for joining us.
It's been a pleasure.
And we'll see you all on the next Deep Dive.